Hello guys. From time to time I get requests of help. People want answers to different things. Well, how do I do this? How do I do that? And by the number of videos I've got out now, I average about 10 or 12 a day, so I try to answer them. But it's not always possible, and sometimes I think, well, I've already given the answer as best I can, but anyway, I'm going to try and answer a few questions. Somebody said, how does an aerial produce waves, radio waves? Okay. Well, I only got it yesterday, so I'll do my best. Little bit of theory. I won't, bear with us. I'm assuming you know what a sinusoidal wave is. That's zero here, and that's positive, and that's negative. If you think of it as AC mains coming out your socket, if it's coming out at, well, if you're in England, it's 50 cycles, so you've got, that's one complete cycle, or hertz, which comprises of one positive and one negative pulse 50 times. If you're in the States, there's 60 of them per second, so that's a sinusoidal wave. Okay, our transmitter produces a sinusoidal wave, and this energy, or the frequency of this energy, the number of them in the length of time, depends on what band we're using. If it's Citizen's band, it's 27 megs. That's megacycles or megahertz. So there's 27 million of those per second. If it's 2 meter bands, it's 145 million of those per second. Hell of a number, isn't they? Anyway, let's just break it down slowly. If we've got an aerial, let's have a different colour. That'll do. I'll make this one horizontal, but it could be vertical. If we put energy into this, if we're putting an RF signal into this, we start off by the first part of time is positive. So we get excess electrons being sent up the wire, or our aerial, and they build up these excess electrons up this end. They can't go any further because that's where the wire stops. So we've got a high negative charge at one end. If we've got high negative charge at that end, we must have an opposite at this end, so this end is highly positive because it's lacking in electrons. Now, if nothing else happens at that one point, just that one point, that half cycle, then the electromagnetic forces, don't forget we've got lines of magnetic force here and lines of electrostatic force in opposite phase coming out and down that way, collapse back into the wire, and the negative electrons try to run back and the positive trying to join up. But before that happens, because it can't travel instantaneously, although it's damn quick, the opposite comes along. So we have, how do I put this? We have an increase in negative electrons and an increase in positive, and we have what's known as resonant frequency. It is when something gets into resonance, it is like the bridge that fell down because the winds were blowing at a certain speed. It is like trying to empty a bath with a teaspoon. You can do it a spoon at a time, but if you get the whole thing starting to oscillate and you get the timing right, you can empty the whole bath by splashing it out. That's resonance. So if this is resonance, and that's to do with length of aerials, gosh, this is a hell of a subject, but I'm doing my best, guys. We build up a collapsing and increasing front of electromagnetic and electrostatic waveforms. And these free electrons, well, they have to go somewhere, and they're lost into space as a propagating wave. And the other end, we're trying to receive, assuming it's the same length, ideally, we have another wire, and those weak waves now hit this wire, and we receive it as a signal, but we only receive a tiny proportion. It's something to do with the inverse square law and blah blah blah. Hey, I don't want to go there. So, before I'm told I'm wrong, and you experts jump up and down and say it's a load of old biffle, with the greatest respect, you try and explain it to in a minute or two of a video, and if you can do it better, brilliant. I'll post a link to your site. Are you any of the clearer? No, he says, it's as clear as mud.